Hi everyone. I'll explain by example 3 of our examples, the function of x squared minus 4, fx equals x squared minus 4 using Newton's method and Halley's method. So we need to find the root. To solve all root finding problem, we need to find the root, and the root is x equals -2 and 2. Next, we need to find the initial guess. P naught, it's a root it's a number close to the root. So the root is -2 and 2, we'll choose -2, and then the initial guess we'll choose 3 because it's closer to 2. And then we select the tolerance. The tolerance, it's a number where we will stop as the stopping criterion. It's less than the tolerance. I'll explain with stopping criterion later. And then the formula for Newton's method is Pn equals to Pn minus 1 minus f Pn minus 1 over f prime Pn minus 1. So that is f prime, then we need to find the first derivative. The first derivative is f prime x equals to 2x. That's the result of the differentiation of x squared minus 4. And then after getting the formulas, we will just substitute everything into the Newton's method formula, and then we will achieve this formula. And now I explain how to solve the Newton's method using Excel. And then I have prepared a brief template, Newton's method, Halley's method, and we'll always start with 0. And then for Pn when n equals to 0, it's same as the initial guess P naught, so it's 3. Our case, we will choose all the digits to be round off to 6 decimal places, and the stopping criterion is the modulus of Pn minus 1, which is the successive term minus the term before, the iterations before, and then modulus. So the P naught is situated at the B4 column of the Excel, and now we will solve it using Newton's method. We will type up a formula here. To type up a formula, we need to be considerate of the brackets. Brackets do play an important role in Excel. And then we just put equals B4, yeah, minus the B4 square minus 4, because Pn minus 1, now it's P naught, it's at B4. B4 square minus 4 divided by 2 multiply B4. Multiply B4. So we'll get 2.16667. So it's round off to 6 decimal places. And then to calculate the successive Pn, it'd be easy. We just drag down. And then we need to calculate also the stopping criterion, which is Pn minus 1. So the first one we cannot calculate because there is no term before here, before this equation. And then this one, we put equals ABS. ABS is the modulus turbine axle. This is B5 minus B4. Okay, we continue down. And then after that, we will adjust the decimal places here if it's not matched. We can adjust more, adjust less. We will just adjust to 6. And then we'll continue. There might be some. Okay. And then we'll stop here. And then this is 5. So the stopping criterion, it's 5. So for Newton's method, number of iteration, it's 5. And now we will try to solve Halley's method. And then I'm going to explain Halley's method first before I proceed. Halley's method, it's the method of numerical method, the root finding problem, another method for root finding problem. Halley's method. Halley's method, the formula, it's Pn equals to Pn minus 1 minus 2 f Pn minus 1 f prime Pn minus 1 divided by 2 f prime Pn minus 1 square minus f Pn minus 1 f prime Pn minus 1. So we need to find the second derivative for Halley's method. And then we will get the second derivative to be 2. And then we substitute all the equations achieve, all the things achieved into the Halley's method equation. And then we will get this equation here. And then it's the same. We will start with 0. And then the P naught is the same as Newton's method. The Pn, when n equals to 0, it's the P naught. And then we'll adjust the decimal places if there is any issues. So there are 6 decimal places here. And then we will see what is P1. And then it's the same. We'll bring this formula, we type up this formula into the Excel. And then, as I have mentioned, we need to be considerate for all the brackets achieved because it will much or less affect the equations. And then we'll put equals to, and then this is the equation. As we see, the bracket is a bit different from what we get in calculator. After we get the bracket, and we use try and arrows, and then this is the formulas we have achieved, because sometimes we do in paper, it's long, it's quite long, and then now we try to use Excel. And then we press enter. We just, because it's in the column of H4, we choose, we change everything to H4. And then we will get this number. And then we see what is N2. And then what is PN2. So its name MBS H5 because it's the column of 5 of H5 by this H4. Then we continue downwards. We change these settings into numbers if there is issues. And then we bring out to 6 decimal places. We continue down. We'll just drag down for Excel, and then we'll get the stopping criterion. We'll adjust this to 6 decimal places. So we have achieved 6 decimal places. So this is how we solve Newton's method and Halley's method using Excel. Okay, so that is how we solve Newton's method and Halley's method using Excel. So that's all from me. Thank you.